Welcome to Voixie World. We're making enterprise-grade AI accessible to everyone by simplifying the technical complexity while giving users direct access to the source APIs at the lowest possible cost. The purpose of this video is to show you how to create the most cost-effective, controllable dubbing using Voixie ElevenLabs. If you have an ElevenLabs creator account, and especially if you have professional voice clones, you'll achieve the most realistic and highest quality voice results possible. During this process, you'll also automatically benefit from accurate subtitle generation, precise translation to other languages, vocal removal, and jump cut silence removal for videos. You can use these applications and sub-applications for these tasks alone if you wish. Remember, while big brands used to avoid AI, forward-thinking companies now specifically request AI voiceovers to show they're embracing innovation. And here's proof. This entire video tutorial was voiced by my AI voice clone, not my real voice. Now, let's dive into the details of how to translate both single-speaker and multi-speaker videos or audio to another language using your own ElevenLabs account. Hi, I'm Barak, and today I'm introducing you to Voixie ElevenLabs, the most advanced AI-powered dubbing solution available. Traditional dubbing costs thousands of dollars and takes weeks. With Voixie, you get professional results in minutes at a fraction of the cost. Let me show you both single-speaker and multi-speaker examples. Let's begin. Now you might ask, why not just use ElevenLabs' own dubbing system? Great question. Let me show you the shocking math with this official pricing breakdown. Look at this. ElevenLabs Creator Plan gives you 100,000 characters monthly. That's roughly 120 minutes of regular text-to-speech. But when you switch to their dubbing studio, those same 100,000 characters get severely restricted. With their automatic dubbing using fast clone voices, you get only 50 minutes with watermark, 33 minutes without watermark. But here's the real shock. If you want to use your professional voice clone that you spent time creating, Dubbing Studio limits you to just 20 minutes with watermark and only 10 minutes without watermark. That's a 12 times reduction from 120 minutes down to just 10 minutes. You're paying $22 monthly, but getting 12 times less dubbing when using your best voices. Yes, you can edit the text, but you're trapped in their severely limited quota system. With Voixie ElevenLabs, your full 100,000 characters stay intact for dubbing. You get your complete 120 minutes, use any voice including your professional voice clones, edit subtitles exactly as you want, and work on your own computer with complete control. That's up to 12 times more cost-effective with total creative freedom. With Voixie ElevenLabs, you use 100% of your Creator Plan characters for actual dubbing. No extra fees. Your $22 subscription gives you roughly 120 minutes of dubbed content instead of just 10 minutes. But that's not all. You're also getting our entire professional ecosystem included: Famast for accurate subtitles, Made for multi-speaker separation, DeepL for professional translation, OLSB for subtitle optimization, and Cut for silence removal. That's 6 enterprise-grade tools with no additional dubbing fees. Traditional studios charge thousands for what you get in one affordable package with complete control over your content. Now comes the exciting part. Let me demonstrate the complete Voixie workflow with 2 real examples. First, we'll dub a single speaker video of Zuckerberg into German. Then, we'll tackle something even more challenging, a multi-speaker conversation between Zuckerberg and Cleo, also dubbed into German. By the end, you'll see how Voixie handles both simple and complex dubbing scenarios effortlessly. First, we'll open our Famast application, which stands for Fastest and Most Accurate Subtitles and Transcriptions. Famast uses OpenAI's Whisper technology, which is the gold standard for subtitle generation. I'm uploading this 42-second video of Zuckerberg speaking English.
The future depends on all of us. And whether you like Facebook or not, I think we need to recognize what is at stake and come together to stand for voice and free expression at this critical moment. It's really great to be here at Georgetown with all of you today. Before we get started, I just want to take a moment to acknowledge that today we lost an icon, Elijah Cummings. He was a powerful voice for equality and for social progress and for bringing people together.
Now, let me show you something incredible about the costs. I can click this Check OpenAI Credit button to go directly to my OpenAI account. This button takes you straight to your own OpenAI credit management page where you can monitor all your usage in real time. If you don't have an account yet, you can log in with your existing ChatGPT account or create a new one right here. Once you're logged in, you'll see the left menu where you can click on Billing to access all your billing information. Let's look at the billing history. This is where you can see the real magic of these costs. Here you can see that I've only added $5 to my account twice throughout this entire development process. Even though I've used credits for multiple other applications and made dozens of test runs while developing these tools, just two $5 payments were more than enough. With OpenAI Whisper pricing at just $0.006 per minute, that means with $5, you can process nearly 14 hours of audio into accurate subtitles and transcriptions. To put this in perspective, while developing this entire suite of applications over the past year, testing dozens of videos and using credits for other projects as well, I spent only $10 total and still have credits remaining. This is the kind of cost efficiency that makes professional-grade subtitle generation accessible to everyone, not just big studios with massive budgets. 14 hours of processing for just $5. That's revolutionary pricing for this level of accuracy and quality. Perfect. Let's go back to the Famast interface and start the processing workflow. First, I need to enter my OpenAI API key here. This connects directly to your own OpenAI account, so you maintain complete control over costs and usage. If you don't have an OpenAI API key yet, it's very simple to get one. Just go to platform.openai.com, sign in with your account, and navigate to the API keys section in your organization settings. You can see here that I have several API keys for different projects. Each one can be named and managed separately. Click Create New Secret Key to generate a new key specifically for your Voixie applications. The great thing about using your own API key is that you can monitor exactly how much you're spending and track your usage in real time through OpenAI's dashboard. Next, I have several input options available. I can use audio or video files, or alternatively, I can select existing JSON files from previous Famast sessions. This is useful when you want to reprocess or modify existing subtitle projects. For this demonstration, I'll select Media Input and choose our Zuckerberg video that we just viewed. Now for the output folder, I've organized my workflow into clear steps. I'm creating an output folder called Famast inside my Step 1 Original Subtitle by Famast directory. This systematic approach helps keep all processing stages organized and easy to follow. It's worth mentioning that we also have T11 and made sub-applications that can generate subtitles, but those are specifically designed for multi-speaker scenarios with speaker diarization. We'll use those powerful tools later in our multi-speaker example to create separate subtitle files for each individual speaker. Now I'll click First Prepare Audio Files for API. This is a crucial step where the system automatically prepares your media files to meet Whisper's requirements. OpenAI Whisper has a 25 megabyte file size limit, so this button intelligently processes and segments your files in the background to ensure compatibility. Once the audio preparation is complete, you'll notice that the Convert Subtitle button becomes active and ready to use. This two-step process ensures reliable processing regardless of your source file size or format. Before we start converting, let me show you a powerful feature that can dramatically improve transcription accuracy. I'll click on Manage Whisper Prompts to demonstrate this advanced capability. This opens the Whisper API Prompt Enhancement dialog, which is a game changer for accuracy. Here you can provide specific context to Whisper about your content using up to 224 tokens. This feature allows you to predefine important terms, names, technical vocabulary, or domain-specific language that Whisper should pay special attention to during transcription. You can see the template system here. I can either choose from existing templates or create new ones for different types of content. For this Facebook Founder video, I'll create a new template called Facebook by clicking Create New Template. In this template, I can provide context about Mark Zuckerberg, Facebook-related terminology, and any specific terms that are crucial for accurate transcription. This is incredibly useful for technical content, proper nouns, industry jargon, or any specialized vocabulary that standard transcription might miss or misspell. The system remembers these templates, so once you create them for specific topics or clients, you can reuse them for similar content. This saves time and ensures consistent accuracy across your projects. Now I'll close this template dialog. You can always choose to skip using templates if you prefer. Whisper will use its latest servers to provide the most accurate transcriptions automatically. Let me show you the transcription model options in this drop-down menu. Here you can see several different types of subtitle and transcription outputs available. The first three options use OpenAI Whisper technology and provide both subtitles and full media transcription. The last two options are newer models we've recently added, but they currently only provide transcription without subtitle timing. We'll cover those in detail in a dedicated Famast video. For dubbing purposes, I'm selecting Sentence and Classical because this option gives us both traditional subtitle formatting and the ideal sentence-by-sentence structure that works perfectly for dubbing workflows. We also have custom word blocks, which is specifically designed for shorts, reels, and TikTok videos. This creates subtitles that display a fixed number of words at a time, which is popular for social media content where each word appears individually on screen. The guaranteed subtitle option uses word-level segmentation tracking to create the most reliable classical subtitles, which is perfect when you need absolute timing accuracy. Since we're focusing on dubbing, I'll stick with Sentence and Classical for optimal results. Now I need to click First Prepare Audio Files for API to activate the subtitle generation process. This step automatically segments our media into chunks smaller than 25 megabytes, which is required by OpenAI Whisper. The analysis happens very quickly in the background. Perfect. Now you can see that the Generate Subtitle button has become active and ready to use. This intelligent pre-processing ensures smooth processing regardless of your original file size. Now I'll click Generate Subtitle to start the transcription process. The system shows me a cost confirmation dialog. You can see the estimated cost for processing this 42-second video is minimal, just a few cents. This transparency lets you approve cost before any processing begins. I'll click OK to proceed. And watch this, the magic happens incredibly fast. You can see the progress bar moving through the transcription process. Famast is now sending our prepared audio segments to OpenAI Whisper for processing. And there it is, completed in just 5 to 10 seconds. This is the power of our optimized workflow combined with OpenAI's lightning-fast Whisper technology. Because our input media exceeded 25 megabytes, the system also extracted the audio as MP3, useful if you need just the audio for other projects. Look at this incredible variety of outputs. We don't just get one subtitle file, we get multiple formats optimized for different use cases. You can see we have classical subtitle files, long sentence versions perfect for dubbing, shorter sentence blocks for better readability, and a complete full media transcription. Each file is precisely time-stamped and ready to use. This is what makes Famast so powerful. Instead of just getting basic subtitles, you get a complete toolkit of different formats, all generated from a single processing run. Whether you need traditional subtitles, dubbing-optimized sentences, or full transcripts, everything is ready to go. The speed and variety of outputs here is remarkable. Professional-grade results in seconds, not hours. Notice the time-adjusted subtitle files. These extend each subtitle block to use all available time, giving our dubbing system more room to work with and reducing speed adjustments for more natural results. Notice the different sentence length options. Long sentence keeps text together until natural sentence breaks, while shorter sentence creates more frequent, readable chunks. Both respect punctuation to ensure natural-sounding speech synthesis. For clearer visualization of the timing blocks, we'll work with the shorter sentence subtitle version. Perfect. Now we have our English subtitles ready. Time to move to step 2 of our dubbing workflow, translating these subtitles into German. I'm opening our main Voixie ElevenLabs application again to launch DeepL subtitle and text translator. This is where we'll transform our English subtitles into perfectly translated German subtitles, ready for dubbing. DeepL is widely recognized as the most accurate translation service available, and our integration makes it incredibly easy to process subtitle files while maintaining proper timing and formatting. DeepL Subtitle and Text Translator uses DeepL's API, widely recognized as the most accurate translation service available. Here's what makes this incredibly powerful. DeepL provides 500,000 free characters monthly, which translates to approximately 6 hours of subtitle content completely free. But here's the key advantage. Instead of just basic translation, our specialized software processes the entire context of your content. We can translate subtitles while maintaining proper timing, formatting, and conversational flow. Plus, we offer advanced features like HTML translation support and formality controls for different audiences. Now let me show you a useful trick for getting your DeepL API key. If you already have a DeepL Pro subscription, the API key section becomes inactive. So here's what I recommend. Use 2 different email addresses with DeepL, one for your regular usage and maybe a Pro subscription, and another specifically for API access, where you can create up to 2 API keys on the free 500,000 character plan. I'm logging into my API-specific account here to grab my key. You can see I have separate accounts. This gives you maximum flexibility and access to both Pro features and API capabilities. Once I have my API key, I'll enter it into our DeepL S&TT interface and click Fetch Languages to pull all available language pairs from DeepL's system. Now, I'm selecting our shorter sentence subtitle file as input. This gives us cleaner block divisions for translation. Here's where our system offers 2 powerful approaches. I can enable sentence-by-sentence translation, which processes each subtitle block independently, or I can use our advanced full-context translation. With full context mode, the system processes the entire text as a whole, then intelligently redistributes it back into properly timed subtitle blocks. This maintains conversational flow and context across the entire video. Now the system asks me to choose an output folder. I'm creating a DeepL S&TT folder within our Step 2 directory to keep all translation results organized. Notice the formality options section here in the interface. As you can see from the info button, this feature isn't supported in every language yet. For example, English isn't in the list since it doesn't have formal-informal distinctions like other languages. German does support formality options, but I won't be using that feature for this demonstration. I'm setting the target language to German and will demonstrate both approaches, first without sentence-by-sentence enabled, then with it enabled, so you can see the difference in results. Now I'll click Translate to start the process. Perfect. Notice how the system shows me exactly how many characters will be consumed from my quota before processing. This prevents accidentally using up your free character allowance on unexpectedly large files. I'll click OK to proceed and watch this. The translation completes in just a few seconds. DeepL's API is incredibly fast and efficient. Perfect. As you can see, the translation process has created various types of subtitle files for us. We now have both classic subtitle format and sentence-by-sentence variations, plus we get the complete text translation of all subtitles in a simple TXT format. This gives you maximum flexibility for different use cases. Now let me enable sentence-by-sentence translation to show you the difference in approach. I'm checking this option here. And this time, I'll create a new output folder specifically for these results. I'm creating a DeepL S&TT sentence-by-sentence translation folder under our main DeepL STT directory. This keeps our different translation approaches organized and easy to compare. Now I'm clicking Translate again. Notice the system shows me the exact same character count warning. That's because we're translating the same subtitle file, just with a different processing method. The character consumption remains identical. Clicking OK to proceed and watch this, the translation completes again in just a couple of seconds. DeepL's processing speed is consistently impressive. Examining our new results, you can see this time we get fewer file variations, but exactly what we need for block-by-block, sentence-by-sentence translation. Each subtitle block has been translated independently, and we still get our complete text translation in TXT format, but now optimized for individual sentence processing. Now let's compare both the sentence-by-sentence and the non-sentence-by-sentence results. Let me arrange them side by side so you can clearly see the differences between these two approaches. You can see the comparison here. Both approaches deliver excellent results with slightly different optimization strategies. For this demonstration, I'll use the sentence-by-sentence approach for clearer visualization of the translation process. This is just a preview of DeepL S&TT's capabilities. We're planning a dedicated standalone version with even more advanced features, which we'll cover in detail in its own tutorial video. Now we have our subtitles ready, so let's reopen our Voixie ElevenLabs interface and launch our OLSB sub-application to perform our next step, optimizing long subtitle blocks detection. With this application, we can detect blocks that are likely to be accelerated based on our detailed analysis and average character count calculations that can maintain a 1.0x speed rate. This way, we can either manually write synonymous versions of the detected subtitle blocks ourselves, or select from different LLMs and models offered by LLM providers, using the help of the 3 most important providers like OpenAI, Claude, or Gemini, to quickly obtain shorter versions of blocks without breaking semantic integrity. Now, I'm selecting the subtitle file we just translated to German using sentence by sentence and first doing a preliminary analysis without sending it to any LLM, just to detect which blocks might need acceleration. I've selected my input subtitle and I'm setting up my output folder named OLSB. So what's the complete logic behind this system? We call it CPS, characters per second, and after extensive analysis of average character counts per second, we've determined the maximum character count each block should contain to be voiced at specific speeds. This way, we check for potential acceleration up to 1.0x, 1.1x, 1.2x, and 1.3x speeds. So for any block, we can predict with very high probability the maximum speed acceleration we can allow. Now I'll first select 14 CPS from the menu, which is the maximum character count for 1.0x, then click Only Analyze SRT to see which blocks have potential to be voiced at speeds higher than normal 1.0x without making any changes to the blocks. I've started the analysis and you can see the results generated very quickly. From this analysis result, I can see which blocks exceed the 14 CPS value, meaning they exceed the characters per second count of 14, which corresponds to 1.0x speed, showing their current CPS values and how many extra characters each block has beyond our selected 14 CPS threshold. You can also see this is generated as an analysis report text file in our selected output folder. By opening this file, we can view the analysis results more clearly, and if we want to use an LLM to obtain shorter versions of blocks that exceed CPS values, we can even see estimated LLM analysis costs, which will be very affordable since we're working with text processing, almost free we could say, for whichever LLM we choose for the next processing stage. Now let's return to our interface and move to the process stage. Here I'll use my Anthropic Claude API key. Even if I enter my API key without selecting the correct LLM from the drop-down, it warns me about the mismatch and asks if I want to switch to the correct one. I say yes, and it automatically switches to Anthropic as our AI model. Here I can see the available Anthropic models I can use. I'll select the new Claude Sonnet 4 model, though the other models would also give quite good results. I'm keeping the CPS target at 14, which was our value from the previous preliminary analysis and refers to 1.0x speed as the default selection. In the drop-down below, the Process Mode section offers several options. Should it automatically change only the problematic blocks we detected in the preliminary analysis, or do you want to select only specific blocks like in PDF printing options, or should it try to bring all blocks closer to CPS 14 regardless of whether they exceed the CPS limit or not? We have these three options. In the next drop-down, we have important features called Prompt Mode with three different options. First, the default option uses our pre-prepared prompts that you can see slightly dimmed below, designed to get shorter versions of relevant blocks in the input language without breaking the subtitle format. Second, the Combine with Default Prompt option keeps our existing first prompt, meaning we still want shorter versions, but additionally we can request corrections to potentially incorrect spellings in the current subtitle. Since LLMs are intelligent, they can detect wrong spellings or parts that might be inconsistent with the flow, leading to much more accurate results. Third, the independent prompt option ignores our default prompts completely and allows us to request something entirely different. For example, we could use the independent prompt option with LLM assistance to directly say, translate blocks to this language, turning our DeepL S&TT subtitle translation into LLM-assisted translation. Or you can give completely different prompts for what you want in these blocks. So in summary, we have quite a flexible app for rewriting purposes. Let's keep the prompt type as default and click Start Processing. At this stage, it gives us preliminary information about how many blocks out of the total will be processed. At this stage, it immediately performs the same process as the preliminary analysis, detects the same things and asks, I'll proceed according to this. Do you approve? It also shows the estimated cost in the same way. We continue by saying yes, and the processing completes quickly. Now let's look at the results. Alongside the analysis report we created earlier, this time we have a process report with subtitles rewritten to be as close as possible to CPS 14. When we open the process report, we can see important values like previous text and final text, showing the before and after subtitle block texts, previous and after character counts, the number of characters reduced, and the previous and after CPS values. Now, if you'd like, let's quickly check in the DeepL application whether these shortened blocks were actually shortened while preserving the same meaning by looking at the before and after versions of these German blocks. As you can see, it has done quite well at trying to reduce the character count while preserving the meaning. We can see that the other blocks have also been shortened by Claude in the same way while preserving their meanings. You can see that this process cost approximately $0, which we could call practically free. Now let's look at these texts in the subtitle files. Two types of subtitles are created. One contains the normal shortened texts, while the other, adjusted version, just like the adjusted results in Famast and DeepL S&TT, provides an adjusted result to further reduce the chance of fast reading by giving longer duration to blocks if there are time gaps between blocks. But here we'll use the original optimized result for the dubbing process to more clearly see that the voiceovers are done at exactly the right times. After completing this step as well, we're slowly approaching the use of our main application. But we have one final step left for the most realistic dubbing. If there are background sounds in our original media, we'll use the vocal remover section of our made application to perfectly transfer this to our dubbed media. For this, we reopen our main interface and launch our made application. In the opened Made interface, we select the Audio Detection and Splitter section on the right side, which is the Vocal Remover section. Here we select our original Zuckerberg video and try to detect the existing background sounds. We want our output folder to be created within a Made folder in our Step 4 directory. After selecting our output folder, we click Process Media to start the process of finding different sounds, especially background sounds. After a short while, we detect 4 different types of sound sections from 4 separate channels named vocals, drums, bass, and other, which don't necessarily contain only the types of sounds they're named after, but can contain different types of sounds. Here we get sound options as both original and normalized. The original ones mean lower level sounds that remain in the background of the current video and don't suppress the main speaker's voice. Normalized means we also provide these sounds at normal levels, brought closer to normal sound levels, in case you want to use this sound at higher and normal sound levels in a separate process or project. Now we detect sounds that could be background sounds by listening to each of them on this screen, up to 2 sounds. First, we listen to the vocals result. In the vocals section, you might think there's noise at the beginning, but actually you can see that it has detected the applause sound in the video when you continue listening. When we listen to the drum section, we can detect that it's just noise. When we listen to the bass section, we can see that it has detected the music playing in the background. And finally, in the other section, we can see that it has detected Zuckerberg's speaking voice.
The future depends on...
If our intention was only to get the vocal sound stripped of background sounds, we could have used this other section as well. But that's not our purpose right now. Quite the opposite. Since these are the sounds that remain behind this vocal, we'll use the original versions of the vocals and bass sections, meaning the versions that don't suppress the main speaker's voice, to add to our dubbing video in our main application. After detecting the sounds, we select them as Pick as Environment Sound, and it opens the folder where these sounds were created. As I said, we'll select the vocals, original and bass original sounds from these as environment sounds in our main dubbing app, where we can add up to 2 sounds. After completing the background sound detection with Made, we can now start using our main application. We're opening our main interface. This is Voixie ElevenLabs, where the actual dubbing magic happens. First, I need to connect my ElevenLabs account by entering my API key. After entering our API key, I click Get Voices and Models, or since our new system now supports multiple speakers, when you click the Add New Speaker button, our system pulls all the voices available in your API key. Next, I'm selecting our German original optimized subtitle that we prepared in Step 3 with OLSB. This is what gives you access to all your voices and models, and each user uses their own API key, so you have complete control over costs. Now, if you haven't obtained an API key from your ElevenLabs account before, let me show you exactly how to get it. We covered this in detail in last year's video, but let me refresh your memory. We're going to ElevenLabs.io and clicking the Go to App button in the top right. After logging into our account, we click the My Account button at the bottom right. In the opened menu, we click on API Keys, which is the second option from the top. The API keys page opens, and here we click the Create API Key button. ElevenLabs automatically assigns a distinctive random name, but we should give it a name based on where we'll use this key. For example, I'm naming it Voixie ElevenLabs. I'm not checking the Restrict Key option below. There's no need to unnecessarily restrict the key. Then I click the Create button, and our key is generated. We only have one chance to view it, so I immediately copy it with the Copy to Clipboard button and save it in a secure location as well. Getting an API key is that simple. If we want, we can later delete any of these keys from here to make them inactive. Just don't forget to save them for repeated use. Now, before we return to our interface, since we have this open, let me show you something important about voice creation. Let's click on the Voices section here. This is where you can see all available voices, but more importantly, you can create your own. I'm clicking on Create or Clone a Voice in the top right corner. In the Open section, you can see the Instant Voice Clone option. This is exactly how I created my Zuckerberg voice clone that we'll use for dubbing, using just a 2-minute sample of Zuckerberg's voice. If you have an ElevenLabs Creator plan, you also get one Professional Voice Clone where you can create your own realistic voice, just like the one I'm using to narrate this video right now. You can see all your created voices in the My Voices section. Here you can see my Zuckerberg Fast clone, also Cleo's clone for the multi-speaker example in this video, that I named for this demonstration. For example, the voice called SBC Pro New PVC 2025 is my own professional voice clone. These voices will also appear in our Voixie ElevenLabs interface when we connect with our API key. The instant voice cloning feature is incredibly powerful. You can clone any voice in just minutes with a short audio sample. This gives you unlimited creative possibilities for your dubbing projects. Now let's return to our Voixie interface and continue with the dubbing process. To ensure you can comfortably view the voice selection screen on different resolution displays, we've provided various font size options and flexibility to this window. This way, you can easily adjust the selection screen for optimal visibility. Notice the font size drop-down menu where you can choose from different point sizes. This makes the voice list more readable whether you're using a small laptop screen or a large monitor. This attention to user experience details is what makes our interface accessible for all users. Perfect. Since we called our API key, all the available models have loaded, as you can see. Here, the 11 Multilingual V2 model is currently the best model for providing high-quality voice across different languages. The 11 V3 model has also arrived in the application, but it's still in alpha stage and hasn't been fully released in the API yet. It's also not successful in every language at the moment. But of course, we'll offer it to you once it's more established and properly integrated into the API. For now, the 11 Multilingual V2 is your best choice for cross-language dubbing projects, especially when working with voice clones in languages other than the original training language. Now, let's continue with the remaining steps to complete our first dubbing process. As an optional feature that we offer, but one I think many of you will use frequently, unlike our 1.0 version from last year where you needed a video editing program, you can now directly select the input video in the original language. But that's not all. Also, as an optional feature, we're adding the background sounds we identified with Made earlier. I'm selecting Bass Original and clicking Add Sound again to select Vocal Originals. If you remember, one of these contained applause sounds and the other had softly playing piano sounds. Finally, I'm creating our output folder as Voixie ElevenLabs, where all output files will be generated. Everything is now ready. I'm clicking the Convert button to start the dubbing process. After clicking, it informs me about how many characters from my ElevenLabs account will be used, and this is where our real difference becomes apparent. We're getting dubbing at 12 times cheaper cost by only using our character credits, plus with our professional voice clone included, with any voice we want, with input video, without any watermarks, the most affordable and controllable way possible. I'm confirming by clicking OK, and the processes begin. You can also follow the workflow from the screen below. We've added a brand new feature here that comes checked by default. You can see the Enable Smart Audio Stretching, Slow Down and Speed Up option. With this, we now apply not just speeding up, but if a block would create too much empty space, even when sped up with normal voice, we slow it down to a minimum of 0.7x to use that block more effectively. This way, we achieve even more fluid speech. Perfect. The process has completed. When I click OK, our output folder opens automatically. In this folder, two folders have been created, Final Output and Speaker A. Since this is a single speaker video, only a speaker A folder was created. Let me first check what's in this folder. Here you can see the dubbed audio files belonging only to this speaker. Additionally, in the unspeeded blocks folder, in our previous version, we only provided blocks that underwent speed adjustment, but now we provide the unprocessed versions of all independent blocks. This way, if you need the normal speed audio of any block, we provide all blocks in this format. Also, going back one folder, you can see the timing info text file here. In this file, you can see which processes were applied to which blocks with which speed factors. Additionally, as an alternative to speeding up or slowing down this audio, it also provides an alternative method for synchronization between audio and video by playing with the video speed between the relevant block durations and selecting the normal version of the relevant block audio from the unspeeded folder. And going back to our output folder, let's enter the final output folder here. Here you can see our dubbed audio file and especially our dubbed video, the one we were really looking for, with the original audio replaced by the new language audio, background sounds preserved, and now in German. Now, if you'd like, let's watch this video in the new language with English subtitles below for reference.
Die Zukunft hängt von uns ab. Ob man Facebook mag oder nicht, wir müssen erkennen, was auf dem Spiel steht und zusammenkommen, um in diesem kritischen Moment für Meinungsäußerung einzutreten. Toll, heute hier in Georgetown bei Ihnen zu sein. Bevor wir beginnen, möchte ich würdigen, dass wir heute eine Ikone verloren haben. Elijah Cummings war eine starke Stimme für Gleichberechtigung und sozialen Fortschritt und dafür, Menschen zusammenzubringen.
As you can see, the synchronized dubbed video was created with background sounds preserved. Since Enable Smart Audio Stretching was enabled, meaning not just speed up but also slow down was applied, you might have noticed the slow speech in some sections. This way, excessive gaps in blocks were prevented. Now, if you'd like, let's disable this feature like in the old system and start the process again to observe the difference. Keeping the same selections, I'm just changing my output folder to be distinguishable and saving it as Voixie ElevenLabs No Slowdown. This way, I'm clicking Convert to restart the process. Let's see what kind of result we'll get this time. The process is completed and we've obtained similar output results again. Let's first look at our timing info folder if you'd like. This time, as we can see, there was no slowdown process in any block. At the same time, since we also did rewriting with OLSB, the character counts in the blocks were sufficient for normal speed voicing, so notice that there was no speeding up either. Normally, when we disable smart stretching, it would speed up if there was a need for acceleration, but since our block lengths were brought to sufficient levels with OLSB, this wasn't necessary either. Now, if you'd like, let's watch our German video for this result. Here we expect a bit more gaps.
Die Zukunft hängt von uns ab. Ob man Facebook mag oder nicht, wir müssen erkennen, was auf dem Spiel steht und zusammenkommen, um in diesem kritischen Moment für Meinungsäußerung einzutreten. Toll, heute hier in Georgetown bei Ihnen zu sein. Bevor wir beginnen, möchte ich würdigen, dass wir heute eine Ikone verloren haben. Elijah Cummings war eine starke Stimme für Gleichberechtigung und sozialen Fortschritt und dafür, Menschen zusammenzubringen.
As you can see, this time no audio was slowed down, but due to the subtitles being further shortened with OLSB, even more gaps emerged. However, in today's modern videos, if you've noticed, to prevent viewers from getting bored, videos with quite a lot of jump cuts that only present the speaking sections and cut all the gaps in between have become fashionable. Taking advantage of this feature, we'll use our cut application called Cut Silences, which is the final step of our prepared applications. You can use this application either to cut gaps in this type of videos or to remove unnecessary gaps in your other video work. In other words, as Voixie AI and Voixie World, we offer you not just a dubbing application, but also many features you can use for different tasks, such as subtitles, translation, and jump cut video editing. Now, through our Voixie main interface, I'm opening my Cutters app in the final step, which can again be optional, but one you can use frequently in other video work. In the opened interface, you can select either video or audio as input file. Moreover, CutS supports high-resolution modern videos like 4K to 8K as well. From the input section, I'm selecting our final output video with excessive gaps since we cancelled smart stretching earlier. Our aim is to remove the gaps in this video. As soon as I select our input video, it warns us that this video was created with H.265, which is a high-quality video codec, but fortunately CutS supports this too, and we continue with our remaining selections. Here you can see the margin time selection and audio threshold value selection screen in decibels. The default values can be called optimum values. The lower you make the margin, it means how much margin should I leave from the two cut ends of a silence when cutting. 0.2 seconds is also a suitable value. If you want even less gaps, you can make this value 0.1 as well. On the other hand, the -30 decibel value is a suitable silence level control value. If you wanted to catch more subtle sounds, you can make this value less negative, for example -20 decibels, or conversely, if you wanted to only catch very quiet sections and ignore small background noises, you can assign more negative values like -40 decibels or -50 decibels, but then the cutting process might be too restrictive. Therefore, our default value of -30 decibels is quite suitable. Then we have two important nice features here. The Keep Sections section allows you to enter multiple values between commas. This means don't perform any cutting operation during the time between the second value pairs you enter. Similarly, the Remove Sections section means directly remove that section or sections completely from the video or audio selected as input for the time between the pairs. From the multiple time pairs you can enter here, and we can directly remove unwanted regions from our video. That's not all. As output type, you can not only create video or audio, but also create files like XML directly determined for famous video edit programs like Adobe Premiere, DaVinci Resolve, Final Cut Pro, and Shotcut, and obtain the relevant XML files for quick import into these programs with cutting operations already done. So we can say CutAs is also quite a useful application of ours. I want a video file as output here, so I'm leaving video selected, and as output folder, I want to create a CutS folder in step 6 and save it as cutted.zuckerberg.mp4, video inside. After setting this up as well, I'm clicking the Process Video Log Audio button to start the gap cutting process. The application does a preliminary progress, and after reaching 100%, it starts the progress again for the actual processes. Now let's wait for this to complete. The process will be completed in a short time, and probably when completed, the video with gaps cut will automatically open. Now our video with unnecessary gaps cut in the style of modern videos has been created. Let's find the video from the output folder and watch this result now if you'd like. Let's see if we've created a more fluid, modern video.
Die Zukunft hängt von uns ab. Ob man Facebook mag oder nicht, wir müssen erkennen, was auf dem Spiel steht und zusammenkommen, um in diesem kritischen Moment für Meinungsäußerung einzutreten. Toll, heute hier in Georgetown bei Ihnen zu sein. Bevor wir beginnen, möchte ich würdigen, dass wir heute eine Ikone verloren haben. Elijah Cummings war eine starke Stimme für Gleichberechtigung und sozialen Fortschritt und dafür, Menschen zusammenzubringen.
As you can see, our video has been transformed into a fast-paced, engaging format that eliminates unnecessary waiting time, exactly like today's modern content. We now have a professionally edited video with seamless jump cuts that maintains viewer engagement by removing all the dead air and silent gaps. This creates that dynamic, contemporary viewing experience that audiences expect from modern digital content, where every second counts and the pacing keeps viewers hooked from start to finish. Let's now move on to our multi-speaker example without delay. In this video, we'll translate the intro section of Zuckerberg appearing as a guest on Cleo's show, which features rapid conversational exchanges and background sounds, into German. First, let's listen to the original English version of this section.
I'd love to start with these.
10 years of work right there.
Someone on your team called these the real-life Tony Stark glasses.
Very hard to make each one of these.
That makes me feel incredibly optimistic.
In a world where AI gets smarter and smarter, this is probably going to be the next major platform after phones.
I miss hugging my mom.
Yeah, haptics is hard.
How does generative AI change how social media feels?
We haven't found the end yet.
The average American has fewer friends now than they did 15 years ago. Why do you think that's happening?
I mean, there's a lot going on to unpack there.
Here's our multi-speaker video. Now let's start the process for multi-speaker dubbing without wasting any time. This time, instead of Famast for subtitles, we need to detect multiple speakers, and we have two alternatives to choose from. We can select whichever we prefer. This freedom and control in Voixie world is truly liberating. One of these alternatives is T11, which stands for Transcriber by ElevenLabs and uses the recently announced ElevenLabs Scribe technology. The other option is using the Assembly AI section of Made, which we previously used for background audio separation in our single speaker video. Assembly AI is another powerful speech-to-text provider that offers $50 in free credits for new members. That's approximately 185 hours of processing, which is an incredible value that really demonstrates the advantages of using the APIs directly. We'll use the speaker diarization features from both T11 and Made's Assembly AI section to obtain speaker-separated subtitles. Now let's start by launching T11 to begin our operations. We've opened our T11 application, where we have many different types of options available. We offer you various subtitle and output formats. Here we can use the same API key we obtained from ElevenLabs earlier, and don't worry, speech-to-text means S&TT pricing is much more affordable compared to text-to-speech. Let's learn about this interesting situation from the current comparison on ElevenLabs' subscription page. While speech-to-text through the user interface website costs $4.5 per hour, which means approximately 5 hours of speech-to-text processing, this value drops dramatically when used with the API key, down to around 35 cents per hour, allowing us to obtain approximately 63 hours of S&TT processing, which is quite substantial and sufficient. We can truly see once again how important API usage is and how it provides us with incredible benefits and cost savings. Similarly, as I mentioned earlier, thanks to API usage, the cost of dubbing minutes obtained through the user interface with auto-dubbing and Dubbing Studio can be reduced by up to 12 times, without watermarks and with the ability to use your own professional voice clones. Through Voixie AI's capability to eliminate intermediaries, we aim to provide you with the highest quality results at the lowest possible cost. Perfect. Now let's return to our T11 interface and use the same ElevenLabs API key we used earlier for the speech-to-text feature as well, and see how we can obtain subtitles for different speakers with the highest accuracy. So, I've entered my API key. Next, you can see the language code section here. It has automatic detection capability. If we look at the info section, ElevenLabs has shared information about which languages the newly released but very successful Scribe v1 model can detect and at what quality level. You can see this information marked with stars in this info section. For example, instead of automatic, when you look at the language section like this, you can see how successful each language is with values ranging from 1 to 5 stars. Here, you can see the speaker diarization feature, which is exactly what we're looking for. It can also automatically detect the expected number of speakers. Scribe can handle up to 10 speakers. I'll leave this selection on auto as well. It can identify not only human speech, but also other different types of sounds. This is quite an innovative feature. As input type, it can accept both audio and video. There's no 25 megabyte limit like in Whisper. You can upload up to 1 gigabyte media file, and this way we can say it has become quite a comprehensive program where we can offer you many different types of subtitle and transcription outputs. There's even a dash feature that provides subtitle types that can be highly compatible with subtitles for TV series and movie videos. There are also timestamp details. You can see what kind of results each type provides from here. We can keep it as Word format. After introducing T11 general properties, let's now proceed with the operations and obtain separate subtitles for each speaker by selecting our video for the multi-speaker example. I selected the Cleo Zuckerberg video as input. As soon as I selected it, it asks me to choose where the output file should be created. I created a T11 folder inside step 1 within the multi-speaker folder. Now everything is ready. We start the process with the Create Transcript and Subtitles button. The process is complete. Now let's look at the results. From these results, what's particularly important for us and what we can use for dubbing are the results in the sentence-based subtitles best for S2SS apps folder. In the subtitle file named Speaker 0, this represents the subtitles belonging to Cleo, who speaks first in the video. Similarly, the subtitle file named Speaker 1 represents the subtitles belonging to Zuckerberg, who speaks second in our video. When we place these subtitles side by side like this, you can see that the speech subtitles belonging only to those specific speakers have been obtained separately thanks to ElevenLabs' Scribe V1 speaker diarization technology. If we quickly look at the other output folders as well, in the transcripts folder, you can see the script of the entire video in the transcript file. In the transcript report file, you can also obtain a report containing details such as total word length, what percentage confidence the result has, how many words each speaker spoke, the most frequently used words, and how many times these words were used. Now, similarly, another application that helps us find subtitles belonging to different speakers is our Made application, as I mentioned earlier. As you can see, we last used this app to detect background ambient sounds in our single speaker video, but this app also has an Assembly AI section. Assembly AI's powerful speaker diarization tool and its generous free credit of $50 makes this app a strong alternative as well. Now in the Made interface, we select the Assembly AI speaker detection and subtitles section on the left side. Then you can see our API key section that we'll obtain from the Assembly AI website. Now let's go to the Assembly AI website and log in to get our API that provides $50 in free credits. When we log in, you can see that even I, including the development phases of this app, haven't even spent 50 cents. Imagine how generous a credit $50 really is. Then we click on the API keys section on the left, and here you can see the API key I created earlier. Now we return to our interface and enter this API key here. Next, there's the Expected Speaker Numbers section. Since we have a video with 2 speakers, we select the value 2 from here. Then we select the Cleo Zuckerberg multi-speaker video that we also selected for T11 earlier as input. Immediately after, it asks us to choose an output folder, and for this, we create our Made folder next to the T11 folder we created earlier. And now everything is ready. We start the process with the Process Media button. That's all there is to it. The process completes in a very short time. Now, let's take a look at the results. This time, unlike T11, we see that it uses speaker A and speaker B naming instead of 0 and 1 numbers for speaker identification. If you'd like, let's quickly compare the T11 and Made results side by side on a speaker basis. For the first speaker, Cleo's speeches, we can see we obtained quite similar results. Similarly, when we place the T11 and Made results for speaker Zuckerberg side by side, although they're very close results, we can see that T11 captured the 10 years part better. The main reason for this is that we're currently using Assembly AI's free version and cannot use their powerful LLM-based model called Lemur. I'd like to remind you that by simply switching to the pay-as-you-go package without paying any fees while preserving our remaining balance from the existing $50 credit, we can easily move to the next level and benefit from these products to achieve results that are at least as successful as T11. For now, we'll continue with T11 from these 2 results. After completing this stage, we can move on to the DeepL S&TT subtitle translation phase. We're reopening our DeepL S&TT application that we last used for the single speaker. Our API key is already entered. For input selection, first we select our speaker 0 input subtitles that we obtained from the T11 results. For the output folder, we create a DeepL S&TT speaker 0 folder inside step 2 in our multi-speaker folder. Since our subtitles are in sentence-by-sentence format, we keep the previous existing selections as they are and press the Translate button with German as the target language. It warns us again about how many characters will be processed, and we say yes to start the process, which completes very quickly. Similarly, we select Speaker 1 from the T11 results this time and create a DeepL S&TT Speaker 1 folder as the output folder. Then we start the translate process again and very quickly obtain the German translated results for these subtitles as well. We can see the German results in the respective folders we created like this. After translating the original subtitles to German for both speakers, we're now getting closer to using our main application for dubbing, but we have 2 more quick tasks left to achieve the best results. One is to detect and rewrite blocks that might be sped up during the dubbing phase using the optimized long subtitle blocks OLSB that we used for the single speaker, if you'd like. For this, we're in the OLSB interface and we select our German translated subtitles obtained for speaker 0 as input and create an OLSB speaker 0 folder inside the step 3 folder in our multi-speaker folder as output. Then we first do a preliminary analysis by saying only analyze SRT to detect blocks that exceed the CPS, characters per second, value for normal 1.0x speed speech. We can see that all 7 blocks belonging to Cleo, the first speaker, exceed the character counts for German. That's why we'll send these blocks to AI processing without changing their meanings. Let's use our last selected Claude API key for this process and see the results. We start the process by saying start processing, and this system also immediately detects with preliminary analysis that all 7 blocks exceed the CPS value and asks for confirmation to send them for processing. We say yes, and the process begins. Our process is complete. Now let's look at the results. When we look at the output folder, we see that 2 types of subtitle files have been created with rewritten versions, one adjusted and one normal. We also see the analysis report from our initial preliminary analysis and the process report created from our final AI processing. We looked at the analysis report through the application interface earlier. Let's also look at the process report. Here we get detailed information about the rewrite operations performed. As you can see, all blocks except block 2 and block 5 underwent the rewrite process with reduced character counts. Now let's check if the meanings were really preserved during the changes, just as we did with DeepL in the first single speaker video. I'm copying the previous and current new final block versions of the first block and checking in DeepL. As you can see, the meaning has been preserved. It didn't make abbreviations in block 2. I think the LLM was reluctant to distort the meaning here. Let's take block 3 and look. Again, we see that the meaning is preserved. Let's quickly look at the other blocks too. I can see that the meaning is preserved for block 4 as well. We said there was no change in block 5. When we look at block 6, we see that the meaning is preserved 1-to-1. Finally, looking at block 7, we can see that it shortened it nicely with a synonymous verb. Here we can also see that the process was quite inexpensive. Let's quickly do all these operations for Speaker 1 Zuckerberg's speech as well. This time, we created the OLSB Speaker 1 folder for output. We select the Speaker 1 subtitles as input. Again, we first do preliminary analysis with only analyze SRT file, and it detects that 5 out of 6 blocks exceed the CPS. Then we start the process by saying start processing with AI processing. And again, like in the preliminary analysis, it detects 5 subtitles and we start the process by saying yes. In a short time, we obtain our newly rewritten subtitles and our process report in the output folder. When we open and look at the process report, we can see that all blocks have been successfully shortened this time. If you'd like, let's quickly check if the meanings have been preserved. Let's look at block 2's before and final text. We can see that the meaning has been beautifully preserved while being shortened. Let's look at block 3. And again, as you can see, Claude applied a nice shortening while keeping the meaning the same. This way, we've also prepared our rewritten subtitles. And now we've reached the final step before the main dubbing process. Just as we found for the single video, we'll also find the background sounds for this multi-speaker video using Made. Without any delay, we find our multi-speaker video and select it as input. Then we create a Made Vocal Remover folder inside step 4, and we start the process to find background environment sounds by saying Process Media. Here come the results. Now let's listen to these results. In the vocals section, we can hear the video background sounds. We'll select this in the main app. Let's say pick as environment sound and open the output folder to try to find the potential 2 background sounds using VLC Player. I'm opening the vocals normalized audio file. Normally we'll take the original version in the main app, but I opened the normalized one to hear the sounds more amplified and clearly. Here we found a background sound. I'm checking if there's another one, and let's listen to Bass Original, which also gave results in the previous video. And yes, here we also found the background music from the video. Still, let's look at the others as well. For example, let's listen to Drums Original. As you can hear, there's only noise, and in the last remaining type, we'll now hear the speakers' voices.
I'd love to start with these.
10 years of work right there.
Someone on
We'll use these 2 results as background environment sounds in our Voixie ElevenLabs application, and now everything is ready for the dubbed multi-speaker video like this. Now we're at the final stage and ready to use our main application, Voixie ElevenLabs, for multi-speaker dubbing. We have both speakers' subtitles and background sounds prepared. Just like in our previous steps, we'll first enter our ElevenLabs API key. Then we'll click the Get Voices and Models button to fetch all the voices and models from our ElevenLabs account. Now we'll use our new feature, the Add New Speaker button, to set up the second speaker configuration. For speaker A, I'm selecting the first speaker, Cleo. I'll choose the original optimized subtitle file from the OLSB Speaker 0 folder. In the voice section, I'm selecting the Cleo clone voice that I previously created using ElevenLabs Fast Clone feature. I'll keep Multilingual V2 as the model since it delivers the best results. Moving to Speaker B section. Here, for our second speaker Zuckerberg, I'll select the original optimized subtitle file from the OLSB Speaker 1 folder. In the voice section, I'm choosing the Zuckerberg Fast Clone voice, the same one we used in our first single speaker video example. Now we move to the optional section. Here, I'll select our original Cleo and Zuckerberg conversation video as input. After processing, the original voices in this video will be removed and replaced with our synchronized German dubbing, along with the background sounds we'll add here. For environment sounds, I'm first selecting Base Original and clicking the Add Sound button. Then I'm adding our second background sound, Vocals Original. Finally, I'm creating a Voixie ElevenLabs folder inside our Step 5 directory where all output files will be generated. Everything is ready. I'll click the Convert button to start the process. Just like with our single speaker example, it shows how many characters will be used and asks for final confirmation. I'm clicking Yes to begin the conversion. You can monitor the processing progress from this panel. Our output folder will be ready shortly, and the process is complete. Opening our output folder, you can see separate output files have been created for both speaker A and speaker B, along with a final output folder containing the complete video. In the individual speaker folders, you'll find the synchronized dubbing for each voice, timing information files with speed factor values, and all audio blocks at their default normal speed. The final output folder contains both the combined audio file with all speakers' conversations and the final synchronized dubbed video in German with background sounds included. Let's add the original English subtitles and watch our newly German dubbed video together.
Ich würde gerne damit anfangen.
10 Jahre Arbeit.
Jemand aus ihrem Team nannte sie die echte Tony Stark-Brille.
Sehr schwer einzeln herzustellen.
Das macht mich optimistisch.
KI wird intelligenter. Dies wird die nächste große Plattform.
Ich vermisse Mamas Umarmungen.
Haptik schwer.
Wie verändert generative KI den Umgang mit sozialen Medien?
Ende nicht gefunden.
Der Durchschnittsamerikaner hat heute weniger Freunde als vor 15 Jahren. Warum glauben Sie das?
Ich meine, da gibt es eine Menge auszupacken.
What you've just witnessed would cost $3,000 at a traditional dubbing studio and take 3 weeks to complete. With Voixie, it takes 10 minutes and costs under $1. That's 99.9% cost savings and 3,000 times faster delivery. Compare this to ElevenLabs' own dubbing system. You pay $22 monthly subscription plus additional dubbing fees. With Voixie, your $22 creator subscription gives you 125 minutes of dubbed content with 0 extra fees. Plus, you get unlimited creative control over voice selection, subtitle editing, and access to our complete production ecosystem. By the way, this entire video was narrated using my ElevenLabs Voice Clone, proving that AI dubbing is now indistinguishable from human speech. The future of content creation is here, and it's called Voixie. This concludes our comprehensive tutorial video. I know it was quite lengthy, and I'm fully aware of that, but I wanted to explain every detail in the most understandable way without skipping any important steps. Now with this method, you have complete control over the dubbing process, determining texts, timing, speed adjustments, using your own professional voice clones, and achieving all this at minimal cost, paying only per character used. For early adopters watching this video, I have exclusive discount coupons in the description below. These won't be available forever, so grab them while you can. If the discount codes are still available in the video description, you can use those for a discount, or you can try the system with full access using your trial key. Ready to revolutionize your video localization? Visit our website, try the free trial, and don't forget to subscribe for more AI dubbing tutorials. Take very good care of yourselves, and goodbye.